Hello everyone, welcome to the channel. In this video, we will see a problems on work done by work energy principle. Okay, so this topic comes under kinetics of particle work energy principle. So here we are going to find the work done by using a work energy principle. Okay, so before getting into the solving of the problem, we will try to understand the formula of those problems. What are the formulas will be used in the problem. The very first one is the work done. So basically the formula for work done is force and displacement. That means just imagine you have a box on the floor and you are applying some force. You are applying some force. So this is your first position, and after applying the force, the box is been moved to some x distance, right? So this is your second position. That means here the work done by the force, okay, because we have applied the force on the box, and because of the application of the force, the box is been moved from position 1 to position 2. So this is nothing but the displacement. So here the work done by the force is equal to force into distance, or else force into displacement. So this is a very simple formula. Work done equal to force into displacement. Okay. There is one more principle. By using this principle, we are going to solve all the problems. That work energy principle. Okay. So the work done by force acting on a particle, so during some displacement. Okay. So if there is any displacement, so during that displacement there is a work done is happening. So this is equal to change in kinetic energy during the displacement. Okay, so while the movement of the box, or else while any particle is moving, displacement is happening. So during that period, what energy is been lost, or else because of the kinetic energy, the work done will be equal to change in kinetic energy. So here work done equal to change in kinetic energy. So whenever we have a word called change, that means higher minus lower. That means higher minus lower. So you can have kinetic energy 2 minus kinetic energy 1, because we have two position, right? So if you are moving the box from one position to another position, second position, that again it is we have two position. That is the reason there is a change in kinetic energy. So work done equal to kinetic energy formula is half into m. So mass will be same, because here we are applying force to the same box, right? And the same box is moving from position 1 to position 2. That is the reason the mass will be same. Only thing is the velocity will change. So that means half mv. So since we have 2, so the v2 square minus half m v1 square. So in simple term you can write half m v2 square minus v1 square. So here this is the work done, or else we know work done is equal to force into displacement, force into s, or force into d, force into x. You can take whatever the notation you need for displacement. This will be equal to change in kinetic energy. The formula is half into m v2 square minus v1 square. So by using this principle, we'll be solving the problem on work done. Okay. So now we'll try to solve one problem based upon this concept, work energy principle. Okay. So here block A as a mass of 2 kg. Okay, so the given data, mass of block A is 2 kg. It is in 2 kg. Okay, as a velocity of 10 meter per second. Okay, so they have given the velocity as well. Velocity v equal to 10 meter per second up the plane. Okay, so they are saying is it is moving upward. The direction is upward, up the plane as shown in the figure. Use the principle of work energy and locate the rest position of the block. Okay, we have to locate the rest position. Okay, see, so initial velocity is 10 meter per second. That means I can take v1 equal to 10 meter per second, and here they are saying locate the rest position of the block. So rest means initially we are moving at some 10 meter per second, so rest means the block going to rest at some position. Okay, that means the velocity v2 is become 0. Okay, since it's a rest position. Okay. Okay, so we have to find the distance. We have to find the distance, that is locate. So to find, we have to find displacement or distance. Okay, I'll write on the same word, displacement. Okay, displacement S or X. Fine. Okay, so we know that. Okay, so before going to the solving the solution, we have to draw the free body diagram for the given diagram. So here, this is the inclined plane. See, this is the inclined plane. So if you take, this is our first position, it's a block A, and they have given theta. So for the theta, they have given the slope. So they are not given the directly theta, they have given slope. The slope is something 4, 3. And we have the same block is moving upward. So the same block is moving upward. This is your position 2. This is your first, second position, and this is your first position initially. Okay. So we need to find the displacement between this box. And if you see here, what all things we'll have, again, if it is inclined blocks, so we'll have the normal and frictional force. So normal will be like this. This is your normal force, normal reaction N. Since the block is moving upward direction, this is the direction upward. Okay, so the frictional force will be downward. The friction is nothing but mu dot N. Frictional force equal to mu dot N. And we'll have a weight will be acting downward. So weight will be acting downward. Weight of the block. Okay. So this is our free body diagram. So you have to find the distance for the second position. What will be the second distance over here? Okay, so we can solve. First of all, we need to find the theta as well. So theta will be equal to tan inverse of 4 by 3. Okay, so opposite by adjacent. Sorry, opposite by adjacent is 3 by 4. We have to find theta is equal to 3 by 4. It's 4 by 3. Sorry, 3 by 4. So if you put in the calculator, tan inverse of 3 by 4, it is 36.87 degree. Okay. Now the block, here the degree is 36.87 degree. Okay, so this is our normal reaction and direction is upward. This will be your frictional force mu N, and here we'll have a weight is acting downward. Okay, the weight of the box was 2 kg. So this can be converted to Newton as well, 2 into 9.81. Okay, so this is having the blocks is in inclined position, so this angle will be the same, 36.87. Okay, so I will take the inclined force with respect to x-axis. Okay, so that means this given 36.87 minus, or it's 90 minus this thing, remaining angle, I get as 53.13. So this angle is 53.13. So I'm taking the angle with respect to x-axis. Okay, so we can resolve this weight force as well. If we resolve, we have two forces. One is 2 into 9.81 cos theta. So we have a vertical force as well, 2 into 9.81 sin theta. Okay, so this is our free body diagram for the block at the initial position. If you see here, we don't know the value of N. So okay, we have to take the mu value as 0.2. mu equal to 0.2. So here we don't know the value of normal reaction, that is n we don't know. So we can use, since the normal is in vertical direction, I can take the equation of second law, Newton's second law, that is f of y is equal to m into ay. So we know that the box is moving in horizontal direction, not in vertical direction. So ay will become 0. So in f of y, all the vertical direction, that is n is moving upward, and minus of this 2 into 9.81 sin theta is acting downward. So it is minus of 2 into 9.81 sin theta, which is will be equal to 0 because ay is 0. So n will be equal to 2 into 9.81 into sin theta. The sin is sin theta of 53.13. So we got the reaction as normal reaction as 15.695 Newton. Okay. Now we can apply the by work energy principle. We know that work done equal to change in kinetic energy. Okay, so here if you see in this block we have so many forces acting. So one is, we have the, first of all we have to check for the direction of the box. The box is moving upward, so that means it is in the horizontal direction, right? So the box is moving in the slant horizontal direction parallel to this slope of the plane. So it is moving in the horizontal direction. In the horizontal direction we have two forces. One is 2 into 9.81 cos theta, another one is mu into normal. Okay, so we have two forces. So work done equal to force into distance, right? So work done equal to force into distance. So this will be change in kinetic energy, that is half into m v2 square minus v1 square. Okay, so forces, what are the forces we have acting over here? We have to only consider all the forces which is in the direction of the block. So we have two forces. One is 2 into 9.81 cos theta, that is the force is acting downward. So it will be minus of 2 into 9.81 cos 53.13, then minus of mu also. Mu is, sorry, force into distance, right? So we have to multiply this force with distance as well. We don't know the force, that is S. Minus of frictional force. Friction we have taken as 0.2 into Newton is, sorry, normal reaction is 15 into 6.95 into distance. So this will be equal to half into mass. Mass of the block is 2. And here v2 square. So v2, that means the second position velocity, that is it is 0 minus 10 square. Because if you see, we have to find the distance when the blocks going to rest at the some position. So we have to find that position. So here they mentioned rest position means the final velocity is 0, that is v2 is equal to 0. Now, or else what you can do is you can write in this manner also, or else you can have all the force into multiply the distance as well, like this also you can write it, no problem. Okay, so now what we can do is minus 2 into 9.81 into cos of 53.13. Okay, so this I got the value as minus 11.77 s minus minus 0.2 into 15.695. So this is minus 3.139 s. This will be equal to, the 2 will get cancelled, this will be minus of 100, right? So we can easily get the s value as well. So minus 11.77 minus of 3.13. okay, so here I got the value as minus 14.9. s will be equal to minus 100. So minus minus will get cancelled, so s will be equal to 100 divided by 14.9. it is 6.71 meter. So this is the required displacement. So this is our final answer. we were about to find the locate the rest position of the block. So it will locate at distance s equal to, or displacement s equal to 6.71 meter. I hope you understood this video. If you have any doubt, you can put it in the comment section. Thank you for watching.